Welcome to the Copernicus Project video series, Teaching Science in 5 Easy Pieces. This module focuses on chemistry. We've formatted the videos so that you can watch them in sequence like a feature film or instantly drill down to a specific video or chapter that addresses your own area of interest. Because some viewers may be jumping around to various chapters and videos, our introductions contain some of the same orientation information. The easy pieces are the 5 E's that comprise a learning model known as constructivism. Traditional education is teacher-centered, while constructivism is student-centered. It's based on the concept that students learn best when they're actively engaged with their subject matter rather than listening passively to a lecture. Studies show that students learn science best by doing science, not hearing about it. The role of the teacher is then raised from someone who is simply dispensing information to someone who structures activities that improve communication, that challenge students' perceived notions, and that help students build on prior knowledge. In this and in each of the other videos, we show classroom examples of how you can use the 5 E's to get students actively involved in their own learning. Each video is broken into 5 chapters, one for each of the 5 E's: engage, explore, explain, elaborate, and evaluate. You may use the menu function to instantly jump to any classroom chapter focusing one of the 5 E's. Each chapter will be preceded by a brief explanation of how that particular E should progress, as well as the roles of the students and the instructor. The first E is engage. It's all about involving the students in something they are interested in. Ideally, it will be tied to science content to be covered later on in the lesson. During the engage, students first encounter and identify the instructional mission.
And so what we're going to be doing today is looking at some of these special products that kind of tie together what you saw on the PowerPoint with what you've circled on your survey.
Here they make connections between past and present learning experiences. They lay organizational groundwork for activities ahead, and they stimulate their own involvement with their anticipation of these activities.
All right, so what I'm going to do with this is this survey. I want you to see if you have come into contact with any of these man-made complex molecules. So you're just going to quickly look over the front and the back and circle any of the ones that you have come into contact with over the last week.
You can engage a student by asking a question, defining a problem, surprising them with an unexpected event, or acting out a problematic situation.
All right, what kinds of qualities would be a good thing to look for as we examine these concoctions that you're creating? Anybody? Okay, Riley.
Like if they bounce, do they stretch?
Oh, good.
The elastic.
All right.
Like that.
This gets a student focused on the instructional mission. It's not unlike the marketing of a product. First, we need to grab the customer's attention. We do that by stimulating a sense of need. Once the student feels that basic need to know, he's motivated to take the steps necessary to satisfy his own natural human curiosity.
To engage the students, I started with showing the students a PowerPoint presentation of some actual examples of natural polymers. Next?
Beaks.
Feathers. Feathers and beaks, okay. Are you putting anything together here, making a connection? Hair. Those are photographs taken of like extreme polymers. So I went through purposely and picked out pictures of like really long fingernails or a wild mustache or really woolly goats so that they'd kind of say, wow, what is that? Are you thinking of how a horn is related to a beak, to a feather, to this hair? Yes. And I'm trying to make the connection where they're going to be kind of thinking, why is she showing us this? Or, wow, is that ever weird looking stuff? So I'm hoping that I can attract their interest long enough to kind of lead in then to the beginning of the lesson. And to make it more suitable for them, where they're going to be actually make a bigger connection is when I give them a survey that has a list of polymers that they've supposedly become in contact with over the last week. And those are simple things like, have they touched something plastic at all? That's going to be a polymer. And they don't really start to think of how chemistry is involved in their actual life until they start maybe looking over some of the listed items on this sheet of paper. So that's how I took care of the engaged step in the 5E lesson. All right, so how are these things connected? What could you say about them? How could you categorize them?
There's like long horns and long hair.
Long horns, long hair, okay. So what other kinds of qualities might we look for as we investigate these concoctions?
The second E is explore. In this step, students experience scientific phenomena and materials firsthand. They examine it and they interact with it.
Okay, with this group, you're going to be testing the sodium silicate, all right? So this is your stock solution. You're going to measure out to begin with just 50 mils. That way we can kind of start off with a control. Then, in order to make this concoction work, you're going to be adding some of the rubbing alcohol to it. So you have your pipettes, and so you'll transfer a certain amount. You keep track of what the amounts are, and then see what it is you get from the mixture when you combine them. So use the paper cups. You've got your gloves on in case you are sensitive to the chemicals, all right, and use the tongue depressors to do your stirring with.
As they involve themselves, students develop a personal relationship to the mission. Working together in teams, students build the base of common experience, which will help them in the process of sharing and communicating.
Wow.
See any change?
It's tending to get thicker. Is it reacting?
It turned creamy.
Let's see if I
It looks like gel.
Yeah. So now we're going to add 1 millimeter of sodium borate to the glue. And we poured about 50. That's perfect. That makes a mark.
Creamy, elastic, sticky, watery, and comfy
And
substance.
Germex.
Wow, this is cool.
The teacher acts as a facilitator, providing materials and guiding the student's focus. It is the student's own inquiry process that drives the instruction during an exploration.
When the students start the Explorer segment of the lab, I had them actually mix up some of the polymer samples. All right, so the chemical that you guys are going to be testing has to do with polyvinyl alcohol, okay? And what you'll do is you'll measure out about the 50 mils in the paper cups of the polyvinyl alcohol, and you're going to be testing it against the sodium borate solution. And each group had a different polymer sample to mix. I wanted them to kind of react and see what it was they were getting in the cup as they were stirring and mixing the chemicals together. And they were pretty excited because they were wondering, what is this going to do? What's going to happen here? And so they start saying, ooh, this is ooey gooey, it's sticky, it's messy, it's gunky, or oh, mine is crumbly and hard. And so they start showing each other, what's yours doing, what's mine, you know, and exchanging information about what each one's polymer is doing.
Anthony, what was the height?
Do it 7.
On the bounce, 26.
26 what?
I dropped it at 90 and it bounced at 26. It's
like
Yeah.
what's the just a second.
yeah.
That's kind of gross.
And then they start to notice that there are little subtle differences in the way the polymers react. Or when they are, you know, one is more stretchy, one is more bouncy, one is more elastic, one crumbles more when you apply pressure, one flows better. And so they start to notice this difference, and so they start exchanging ideas back and forth. And they have to devise a method of doing some sort of measurement so that they can make a comparison, so when they do compare the different types of polymers one to the other, that they'll have a concrete way of describing the difference. You want to start it at one height and drop it, and then you're measuring to say where it bounces to.
Oh my god, this is hard. Like almost
26.
26? All right.
And so we always want to, scientists always want to throw in numerical values and qualitative and quantitative descriptions as well. So we want to have some way that they can actually give a description of what happens to it.
Okay, so write that right here, and then maybe. Oh, I know. We can like draw it out like in 1 milliliter, and then we'll put how big it was, and then 2 milliliters.
Yeah, like
we'll put how big it was, and then
size of a
4,
little ball.
5, and then.
Yeah.
The third E is explain. This is when your students, all of them, explain what they found during the explore stage. Language motivates a student to sequence events he experienced into a logical format. Communication occurs several ways: between peers, between the teacher and students, and within the learner himself.
Oh, wow, look at that. Huh. How much is that you added to it?
2.5.
Oh, 2.5? Look at that one, wow.
Okay, and this is one.
Oh, what is this?
Yeah, that's one.
Look like snot.
You can't stretch it that far.
Why'd you leave my other one over there?
All right, how are we doing over here?
Oh my goodness.
There's big changes.
Is there a difference? Are you
Yeah.
finding a difference?
Yes.
Okay, well now keep in mind that you want to come up with some way that you can make a quantitative comparison here.
Working in groups, learners support each other's understanding as they talk about their observations, ideas, questions, and hypotheses.
So
There was not enough. It was small little chunks.
So what, none?
None.
Yeah, it was. Yeah, it was
We can say none.
And then the qualities.
unless we had like force it.
What was
Yeah.
the qualities?
This process leads to a communicable label, which gives a learner the means for sharing explorations. A common language enhances the sharing and communication. The teacher can augment that common language by providing labels for student findings and events that correspond to historical and standard language. The students' created works, such as writing, drawings, video, or recordings, provide tangible evidence of their progress and growth.
In the explain portion of the lesson, the students were supposed to take the information that they collected during the explore and then kind of collaborate with their fellow group members and come up with a way of designing a poster to show what they actually found.
We also need to make one on how glossy they are.
Oh,
Does that make sense? The glossiness.
Yeah. And it's
So stretchy. And then what? So what else could we also?
so this one's not stretchy.
Rigidness.
Rigid.
Rigid, yeah.
And this would include their idea of what their polymer was about, and rank it in terms of its elasticity, its resilience, its flexibility, its fluidity. So they were kind of comparing the different qualities of their polymer and putting it down on paper in terms of a graph, and those that took their measurements had some sort of a way to compare what the changes were when they were mixing the polymers, how that affected those different qualities of the polymer. Again, comparing the qualities and features that they have, and then you will be sorting them out.
Put the name as well, like whatever the name of the.
Right, you can give the name of the example and kind of come up with a different category how you sorted it. And so by displaying this information on the graph or on their poster, then they could then present it to the other class members. All right, so on this marketing advertisement, you're going to try to make sure that consumers are interested in buying your product.
Okay.
So please include the name of the product, you give it a name, come up with what it is, some sort of a slogan or a sales pitch, and then you need to explain how it's used or what its purpose is, and then finally, what are the selling points? And this is where you're going to kind of tie in those qualities that you discovered when you were investigating it with what the practical application of it is, okay?
The fourth E is elaborate. This is the application portion. Can the students take what they've learned and apply it to a new and different area or setting? Here, the students are encouraged to expand on new concepts and make connections. They apply their new understanding to the world around them. These connections often lead to further inquiry and new comprehension. This can lead to that special aha moment in a student.
In the elaborate section of the lab, I wanted the students to take the information that they found out about their polymer and come up with a practical everyday use for it. And to do that, to present it, I wanted them to come up with some sort of an advertisement or even a marketing media package where they actually gave their polymer a name and then they showed on another poster how they would present that in terms of like a TV commercial or an advertisement in a paper. All right, this group is going to share out with what they found from the investigation. They're going to go ahead and give us the name of the polymer they tested. They're going to describe the qualities and the properties they discovered. They'll go ahead and give us some sort of a change, a description of the change that they discovered when they added the various amounts of either the sodium borate or the alcohol. They're going to have a graph and a data table I hope to share with you to kind of substantiate their evidence. And then they'll also come up with some sort of conclusion that gives you a final description and tie up what they found from their particular concoction. So take it away, guys.
You can see how with more and more 2 milliliters, 3, 4, 5, 6, and 7, it was really small, and then it started growing until it really got really big. And like when it was about 4 millimeters to 7, it started bouncing. It could bounce, but when it was smaller, it couldn't bounce.
This group is going to give us their advertisement for the polymer that they tested. So I'll let them go ahead and explain what they named it and how they're going to convince you to buy their product.
Okay, our product is Press and Seal, and we zap to your gap. Basically, it's easy to spread, smooth, it's fast drying. You can use it anywhere, and it's available in 4 colors, and it's only $29.95.
And so now what we're going to do is we're going to see how this particular group categorized their plastic samples and how their polymer fit into those categories. So I'll hand off the basket to you.
All right. So what we did was we took a bunch of household plastics, and the way we categorized them was we categorized them to see if they were stretchy or rigid, bouncy or bendable. And what we did is we just checked marked those different types of qualities for, like, for example, this wire ball.
The fifth E is evaluate. This starts with the student's self-evaluation. They reflect on their own learning experience. It's also an ongoing diagnostic process that allows a teacher to determine if the learner has gained a good understanding of concepts and knowledge. Evaluation and assessment can occur at all points during the instructional process. Concrete evidence of learning becomes apparent as students, teachers, parents, and administrators communicate. This evidence of progress guides the teacher in further lesson planning.
Okay, class, we've had a chance to take a look at some of the qualities that your polymer had, right? By comparing, and you've heard your other classmates give share out on what their qualities of their polymers were. So now what we're going to be doing is we're going to be actually taking a look at some household polymers, some of the ones that you actually circled on your survey. And we want to find out, based on the evidence from your experimentation, how would you categorize your polymer with those actual manufactured ones?
The evaluation process is continuous and gives the 5E model a cyclical structure. It's open-ended and open to change. You'll probably find an ongoing loop where questions lead not only to answers, but also to more questions. This can become a jumping-off point for even greater enrichment of the student's education. Instruction is driven by both a predetermined lesson design and by the inquiry process itself.
With the 5E lesson, a lot of times students are really unsure of what to do. They struggle, and you can see, and that's kind of a nice thing or a neat thing for an instructor to see, is that they're struggling, because that means that they're going to be thinking about this process. So many times they get in a hurry and they want the answers right now. In the 5E lesson, they have to work through, they have to share ideas, and it has to be hands-on because they have their hands actually on the materials that they're working with.
So more harder and clumpier?
Yes.
Wow, look at this.
Well,
I feel like
smells.
it's become
Stuff like this one.
which is slimy.
This one's like slimy, but it's it's not stretchable really, because as soon as you stretch it, it breaks off.
Yeah.
I think it's important that you look at all different kinds of methods that you can excite your students with. One of those is the 5E lesson, and it forces the students to be active participants. It takes away from the cookbook recipe following of labs, and at the same time it gets the students out of, especially in chemistry, doing day-to-day solving of problems. And it helps the teacher actually make sure that the students are actively involved. You can go around and see the thinking process going on, the collaboration, the sharing, and it's really exciting as a teacher to watch the students develop through this process. As another teacher, if I were explaining this to them, I know that it can take a lot more time planning and setting up, but it's well worth the time invested.
This is just one of 5 videos demonstrating the 5E method as an effective teaching tool. The full series covers physics, biology, chemistry, earth science, and elementary level science. The Copernicus Project and the University of California, Riverside Graduate School of Education created this series with a vision for shaping ideas, shaping minds, and shaping the future. For more information on the Copernicus Project, please visit our website at copernicusproject.ucr.edu or call the number on your screen.
Copernicus Project is a cooperative venture of UC Riverside, the Graduate School of Education, and Dean Stephen T. Bossert, the U.S. Department of Education, and the Office of Post-Secondary Education. We're grateful for the support of many other educators, institutions, and faculty members like you.